All right. Good morning. My name is Madison Walker, and today I'm going to talk to you about Truparella pyogenes. So first, I've got the current taxonomy of Truparella written here. I just thought this was kind of interesting because for a while there was a little bit of a debate about whether it was a bacteria or a fungus because people thought it was a sporophyte, that it was producing spores. So its original classification was in the genus Actinomyces, which are fungus. It was then later reclassified to Corneobacterium once they understood that it was not actually producing spores. Then it was later renamed to Arachnobacterium. Wasn't really clear why that was, but in 2011, it was renamed to Truparella, and that's the current genus that it goes by. Some general information about this bacteria is that it's gram-positive, non-motile, non-spore-forming, facultative anaerobe. So, of course, it's got the cell wall with no lipid polysaccharide outer layer. It doesn't have flagella that are able to move it around on its own. It doesn't form spores, and the fact that it's a facultative anaerobe makes it very adaptable to both aerobic and anaerobic environments and can grow quite well in both. It is a rod-shaped organism. It has fermentative metabolism, and it's proteolytic, which can cause some problems. It also has a beta hemolysis when grown on blood agar. So where is it found? It's ubiquitous in soil. It's kind of what gives dirt the dirt smell that you may be used to. So it's found pretty much anywhere animals are found. And it's a commensal organism that's part of the skin, the upper respiratory tract, and the urogenital tract of most animals. Some specific places that it's been isolated from in the literature are the rumen, the stomach of swine, the udders of cows, and a variety of other places. So it's a pretty common organism. It's not hard to find. It's not hard to grow. Now, it is a virulent organism, and it is important to understand how a commensal organism becomes an opportunistic pathogen. So most often this is due to epithelial damage. There are a couple different examples of this. A scrape or a scratch can be enough to do it on the udder or in the skin. Of course, improperly performed surgical procedures like castration, dehorning, or just not changing needles enough when giving vaccinations can be an opportunity for this organism to colonize. And then, of course, more traumatic events like parturition. Infection is rare in humans and horses, but it's pretty common in the livestock species that we are concerned with, cattle, swine, and small ruminants. And like most things, it's rarely in pure culture. When we do see infection, it's often involved in a polymicrobial infection, and it has strong interaction with gram-negative bacteria. One of the most interesting being Fusobacterium necroform, which we'll talk about a little later. The common presentations of this infection are metritis and endometritis. You've got foot rot, mastitis, also pneumonia, and liver abscesses in feedlot cattle. So it can, like I said, it's pretty diverse. It can be found in a lot of different places, and it can cause a lot of different disease states. So like I said, we were going to talk about the symbiosis with Fusobacterium necroform. And it's long been understood that the two are often found together and grow best together, but the exact mechanism why is still kind of eluded scientists. What we do know is that there's an unknown product of pyogenes that stimulates the growth of necroform. And since necroform is a strict anaerobe, it decreases the oxidative pressure and reduction potential of the host in the general area of infection. This favors its own growth. It also produces a leukotoxin, which helps protect pyogenes from attack from the host immune system and any antibiotics that may be present. Finally, pyogenes produces lactic acid as a byproduct of its fermentative metabolism, which is a substrate necroform uses in metabolism. This interaction results in putrid smelling infections that produce a lot of pus and are pretty easily identified when we make good observations. So what are some challenges to treatment? The first and foremost is just the nature of the infection itself. The fact that the infection is located in abscesses means that a lot of the bacteria are surrounded by other bacteria, and it makes treatment with antibiotics difficult because even if the antibiotics reach the bacteria on the outside, there's sort of a meat shield that prevents them from reaching those on the inside, and the infection just kind of continues to snowball and gets bigger and bigger and produces a more and more anaerobic, a larger space for that anaerobic environment, and that favors the growth of both bacteria and just kind of gets out of hand. Usually we like to lance abscesses to really get in there and drain a lot of that stuff out and kind of get better access to antibiotics. But in the cases of interior infections like your metritis or your liver abscesses, that's not always possible. It's kind of easy when it's right there on the neck, but on the inside, it's much tougher. Another thing from a biological standpoint is even though Trupperella is gram-positive, it actually produces a biofilm similar to the lipid polysaccharide membrane that gram-negatives produce, which helps protect it from antibiotics and the host immune system. And then, of course, antibiotic resistance is a problem. It is gram-positive, so it's susceptible to most of our cheaply and readily available antibiotics, but overuse has led to some resistance issues. So what are our treatment options? As I said, infection is pretty common and most people recognize it. What should we do to treat it? Luckily, this is still high sensitivity to fluoroquinolones and cephalosporins. So those are your best bet if you're gonna use an antibiotic as a treatment. But it has become resistant to tetracyclines with only a 9% success in infections that are treated with tetracycline going away. So since antimicrobial resistance is such a problem now with this organism and in animal agriculture in general, there has been research looking into alternative methods to treat this and other pathogens. And in 2018, there was success in discovering a bacteriophage that actually dissolves the biofilm that Trupperella produces, making it more vulnerable to host immune attack and, just more could be used in combination with antibiotics to help make it more susceptible to some of those that's developed resistance to. And then ideally, we wouldn't have to treat, we would be able to prevent infection. And so vaccination is something that we're really looking into. To this point, there's no vaccination for Trupperella pyogenes. And there has been one success where Trupperella was in combination with 2 other bacteria and shown to reduce the incidence of uterine infection in first calf heifers. But that vaccine never made it to market and is still in the research phase. So for producers, there's not really much they can do other than, following proper vaccine protocols, changing needles often, trying to maintain aseptic procedures when castrating and doing other surgical procedures, and just keeping an eye on cuts and trying to keep everything nice and disinfected and clean. What is the importance of prevention and treatment? So from an economic standpoint, there's a huge strain on the dairy industry that's caused mostly by this pathogen. Mastitis costs the dairy industry about $2 billion per year and is in large part attributed to infections from this pathogen, usually transmitted via flies or other ectopic parasites. Postpartum uterine infection, which kind of groups metritis and endometritis together, it affects about 20% of the dairy herd and costs a producer about $512 per case. So that's really eating up any profit that they could hope to see on that animal. And if that uterine infection becomes persistent and becomes a pyometra, then you're looking at a reproductive failure and a cull. And when we cull animals, we are not making any money. Kind of on the beef side, especially on the feedlot cattle, condemned livers are a huge issue still. And the most recent beef quality audit focuses on reducing the amount of condemned livers. I think we're at about 30%. The data for 2021 hasn't been published yet, so it'll be interesting to see if we've made any improvement on that front, but this organism has a lot to do with that, especially as we push those cattle really hard on feed and kind of get them close to an acidotic state and reduce the epithelial integrity of the rumen there. And then just some animal welfare and efficiency issues in the small ruminants, also in the beef. This can kind of go for everything. Foot rot's not comfortable for the animal. They don't want to walk. They don't want to eat. It's a welfare issue. It's an issue with gain. It's something that we need to get a hold of. And just general abscesses, it makes the animal sick. It's just not what we want. So with that, I just wanted to share some of my resources, and that'll be all. I hope y'all enjoyed my presentation.